Alrighty, so I posted some more conversion problems online and I made a Kahoot and we're going to start there and then I can go through how to do the problems. But next week, so starting tomorrow, because our weeks start on Wednesday, which is kind of weird, but really works for me. We're going to be doing something called nomenclature, and nomenclature is the system of naming things. And you know how sig figs are like, oh, sig figs? Nomenclature, more so. Like you really want to understand nomenclature because you don't want to keep losing the same points. And so tomorrow I'm going to have a Kahoot, not a Kahoot, I'm going to have a Zoom where I just talk about some basic things. But let's say that you don't come tomorrow. You can still be prepared. Let me show you what this week looks like. Okay, so I have made the module, but it's not maybe open yet for you. And here it is, week 5. Our discussion will be how do you prepare for the exam. There's content, families of elements, and a little quiz. There's content, weighted averages, and a little quiz. And then there's ions and ionic compounds. And then lab. And there's a lab quiz, and there'll be one skill thing. And the skill thing will probably be on conversion factors. So I'm going down to this page that says ions and ionic compounds. And then here's a video that covers this. So for tomorrow's Zoom, if you could have watched this video, I think it will make things make more sense. And then for Thursday, Friday, Saturday, I'm going to post some nomenclature, practice problems, and then I'll walk through how to do them. And once we're pretty comfortable, I'll do some Kahoots for that. So just so that you know, tomorrow is week 5. Week 5 covers 2 sections in the book, which doesn't sound like much, 2.7 and 2.8. But there's 3 content pages, families of elements, weighted averages, ions and ionic compounds. I intend to spend each Zoom this week talking about ions and ionic compounds because it's just a thing that takes practice. And the more you try the problems and then see them worked out, the quicker you'll learn how to do that. Okay, so it's 4 o'clock. I hope most of us are here. We only have 19 people today. That's okay. Are you ready to do the Kahoot? Does anybody have any pressing questions? Okay, here we go. So the 3 of you that aren't with us, you can still join. Just jump in. The code, I believe, will be at the bottom. There it is on the bottom right. There's our pin. Sig figs. Mikhail, you're on fire. Enjoy your moment. All righty. So, pressing questions first. You just need to know. And then we'll do them all. Okay, anything else? And here we go. So, you know I love when you talk to me.
See if I could go. I'm sorry.
Yeah.
That's funny.
It's just me and you, me and Melissa. Where's Courtney? Is she here today? What about Marilyn? Nope. Okay.
I thought I saw Marilyn. No.
I don't know. I only hear you, but I'm happy to hear you. Okay, number one, here we go. So understand that I'm not doing these for my health. I'm doing these because I think they help you. But if there's things you need, like if you're a person sitting out there, it's like, if you could just do 13, I could be done and go home. Or you are home. I could be done. Tell me. I'll do it first. We did that last night. It was totally fine.
I mean, 13's like what's on my mind because it's a cylinder situation, but.
So Melissa, do you want me to start there or do you want to?
No, I'll wait it out and watch you do them all. I need the practice.
You're so good. You're such a hard worker. You're willing to put the time in and I love that. Okay, so we're going from volume in liters to volume in cubic feet. And there's probably a couple ways we could do this. But I'm thinking cubic feet, I could get there from inches and from centimeters. Oh, wait, a milliliter is a cubic centimeter. So that's going to be my path. Now I have volumes and I'm stepping over here from things that are volumes without being cubed to things that need to be cubed because they're length times length times length. And so I'm gonna have to start cubing things. And if anybody has any questions and you feel a little bit like, oh, I probably shouldn't even have that question. I don't know why I have that question. It's okay to ask. Get scrappy. Ask for what you need. Okay, so something I noticed watching the Kahoot answers tonight was sig figs are still an issue. So we started with 2 sig figs. And there was nothing along the path that limited our sig figs. So we should end with 2. What possible things along that path could limit sig figs?
If you had like a rate, probably.
Exactly. And what else?
Densities.
Yes, those are the two things so far. Exactly. And they're pretty much the two things. Good job. Who was that male voice I just heard?
Mikhail.
Hi, Mikhail.
Hey.
Oh, Mikhail, number one on the podium.
I made some sloppy errors, but thank you.
I'm starting to see a trend though. You consistently are at the top. So that's awesome. Right, 3 days in a row, right? I'm not making that up. Am I hallucinating? Oh,
2 days.
Okay, still. To me, we're going from a mass in milligrams to kilograms. And so it's just a prefix conversion, and those are going to happen a lot. So milligrams to kilograms, I can't necessarily do in one step. But I'm going to show you how. I have to go through the base unit. So in my head, I'm thinking, let me write a relationship between milligrams and grams that is true and puts milligrams on the bottom so they can cancel. 1,000 milligrams is a gram. And then let me find a relationship between grams and kilograms that is true. And this time I want kilograms on top because I want to end with kilograms. The question says how many kilograms. And I know that there are 1,000 grams in a kilogram, or 1,000th of a kilogram is a gram. So that's what I'm going to do is I'm going to put this, I'm thinking this, but I want to combine these into one step. I'm going to switch together. And so this is what I'll do. I'll just put my 10 to the negative 3 up here. So what I have in the denominator is a gram. And what I have in the numerator is a gram. So I'm multiplying by some variation of 1. If that makes sense, excellent, great. Okay, and then the next little problem here is sometimes people aren't sure what to do with those exponents. So we could say, if I have x to the negative 3, and on the bottom I have x to the 3, that is equal to x to the negative 3 minus what's in the denominator, x to the negative 6. And so what I have here is the right units now, but 10 to the negative 6, and what I have here is 6. Questions on that? Okay, so this one I keep doing because I know it catches people and I want you to learn. How many sig figs am I starting with? 3. 2. This 0 is a placeholder. It's just keeping the 2 in the hundredths place where it needs to be. If it wasn't there, this number would be 10 times larger. So that is not significant. It's not a sig fig. Okay, I'm headed from an area in meters squared to an area in inches squared. And I can go from meters to centimeters to inch. But because we're talking about area, everything needs to be squared. The number isn't squared. The number wasn't squared. It's not in parentheses. Just the units are squared. So I have no idea, as I say all these words, what is helping or not helping anyone out there. Because only Melissa and Mikhail will talk to me. And if that's how you're comfortable, that's fine. But I feel like probably the group would get more out of it if more of you people spoke.
I know I got some wrong during the Kahoot, but I forgot which ones specifically I got wrong. So it's like I don't know what advice to give you for you to help.
That's fine. But as I'm going through a problem, if something pops in your head, you're like, well, does that mean this? Just speak it out, okay?
Cool.
Thank you. Number 4. So now we have a cylinder, and the cylinder has a volume, and the volume is pi r squared times height. So pi r squared is the area here, and we multiply by height, we end up with a volume. A lot of times when we're working from mass to volume, typically we go through a density that is in grams per cubic centimeter. So centimeters are really great length units for a problem like this. For this problem, it was given in centimeters, and then for 13, it wasn't. There were some millimeters in there. We had to deal with that.
Hey,
Okay.
Sue,
Yeah.
is height the same as length in this? Because in the book, I think I looked up, especially for problem 134, because I used this equation, but I put L in there for the H. Okay.
That's fine. Okay, so I had students ask this question on the first experiment, which is not graded, but I have been working. I promise you I'm working every day, but experiment 1's a lot to grade. So if your last name starts with A through B, you're fine. The rest of you are gonna have to wait, and I'm sorry about that. Okay, so here we have volume of a rectangular solid is length times width times height. And I've had students ask me, more than one, and every semester this happens, which one's the length? And the answer is whichever one you decide. Typically, we think of length as being sort of horizontal, and height as being vertical, and width as being something else. But it really just depends how you turn your rectangular solid, which one is which to you. So L, W, and H all are the same thing as long as you take different measurements. The measurements I need are, I need one of these, and one of those, and one of these. And it doesn't matter which you label what. So Melissa, length and height could be the same thing.
Okay, cool. Thank you.
Yeah, totally doesn't matter. Okay. So I can start with the volume, and I can get from the volume to using the density to the mass. And the question says what mass is. So volume equals pi r squared, and r is 0.2 centimeters. And I'm fine with that because I'm going to use density, which has cubic centimeters, so that actually works just fine. And then the height or the length is 3 centimeters to 3 sig figs. So now I have centimeters squared times centimeters. That's cubic centimeters, and they can cancel with the density. So I was noticing that sig figs keep happening, and I just want to point out, where do sig figs happen here? Every measurement. Centimeters are things that are measured. Density is a thing that is measured. Pi has a zillion, like it's unlimited and it's sig figs, but this is 2 and 3 and 2, so my answer has to stop at 2. Questions?
Yeah, I have a question. So if like the way I worked it out on the paper, I found the volume by itself first and then plugged it in, but like instead of just putting it all in together, if I'm just finding the volume first, should I just write out the whole number, or should I round it to sig figs there?
No, keep the whole number.
Okay.
Don't round until you're ready to report the answer. The next thing is, I'm noticing as I grade things, people, like here, you would start with volume equals pi r squared h. And then you can put in what the numbers are. And then you're going to come up with a value. I don't remember what my value was, but it was 2.1 something something. Like there were more digits. Oh, I'm sorry. That's a volume. And then I came up with a volume that had a lot of sig figs and units that were volume units. And then I say density equals mass divided by volume. So I'm writing the equation with variables and then rearrange to find what you're going to solve for. I'm going to solve for mass. And then plug in your numbers. Get an answer that has a bunch of digits and units. And then round the correct way and box it. So I'm noticing that students aren't presenting the work in a way that has first the equation and variables, then the equation may be rearranged, and then the numbers plugged in, and then the unrounded answer, and then finally the rounded answer presented either highlighted in a circle or a box. So it's easy for the grader to find. So it steps out, like it pops. So if you did it in 2 steps, totally fine. If you can do it in 1, that's great too. But the point is just when you present your work, make sure that you are very clear about this formula, rearranged to solve for this. Here are my numbers. Here's the complete answer. And now I'm presenting you with the correct sig figs, and that's when we round, only at that very last step. Okay, so now we have a volume in gallons that we're changing to a volume in cubic inches. And I'm going to go from gallons to quarts to liters and to milliliters, which is the same as a cubic centimeter. And then I can cube things and get to cubic inches. That's my path. Questions? Okay, here's one. Go ahead.
Okay, so see how it says like 1.70 or 17000 basically. How, or I guess that's significant figures. So if there's 2 significant figures, you would instead of saying 17000, you'd say 1.7, and then that's significant figures. And then you
Yes.
10. Oh.
Those are the sig figs right there. And we started with 2, and we had unlimited, 4, unlimited, unlimited, unlimited. So we should end with 2.
Okay, I confused me because whenever there was like, let's say there was like 2 significant figures, and you had an answer that had 3 digits past or like before the decimal point, I was like, oh, so it's like 2 significant figures after the decimal point, right? Like,
But sig figs can be before or after.
oh,
When we multiply and divide, we count all of them. And when we add and subtract, we only look at the ones after.
gotcha. Thank you.
Sure. Okay, miles per hour to meters per second. As you know, there's 2 paths. One goes through kilometers and one goes through feet. Anybody have a preference?
Kilometers.
Kilometers, you say?
Yes.
Certainly. Oops, and then we're done. And now we're just going to go the other direction. This time I will go through feet. Okay, so here's an example of a thing that happens a lot. So we started with 3 sig figs. Unlimited, 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 but you plug it in your calculator and it gives you 2 digits. You have to know to add the 0. The calculator is not helping you there. Okay, so here we have density is mass divided by volume, but the volume was determined by displacement. So we started with 38.2 milliliters of just water. And then we have 45.2 milliliters of water plus objects. We subtract to find how much of that volume is the object, and the answer is 7.0. So in the tens place, 0.2 minus 0.2 ends up being 0.0, but that is significant. That is still the estimated digit. In the tens place, we've lost. And so we've gone from 3 sig figs in the measured things down to 2 sig figs once we've obeyed the rules of sig figs for subtraction. Alrighty, number 9. We're just going from mass to volume using a density. Densities have limited sig figs. This one has 3. So our answer is limited to 3 sig figs. And now we're going the other direction. Oh, this one's going to kilograms. How exciting. Okay, so we have cubic centimeters, which is a volume, 3-dimensional. And we know a cubic centimeter is a milliliter. And then we're given a density 13.5 grams per milliliter. It looks like mercury. And we end with grams, but because the number was so large, I said keep going to kilograms. Because I didn't want to use scientific notation, and the prefix can take care of that for us, which is convenient. Okay, number 11. We're using a rate to go from a volume to a time. So here we're starting with 3 sig figs, and we have conversions that are unlimited until we get to this one. Rates are limited in their sig figs. This one has 2, 3 sig figs, unlimited sig figs, 2 sig figs. That's a smaller number. We end with 2 sig figs. Ten millimeters is a centimeter is really convenient to know. And you have one of those little ruler bees so you can see that. So here's another example of you have to watch the sig figs. You started with 2, nothing limits it, and the calculator just gives you 1.08. So you have to add this 0 to have 2 sig figs for that final answer. Okay, Melissa, are you still there?
We're doing just 1 second. I'm copying the last one, so don't start yet.
Okay, I won't start yet. I'm curious how many people are left. 19. Awesome.
I'm ready for 13 now. Thank you for waiting.
Okay. So we're going to go from a volume to mass. And to find the volume, we're given information about the radius and the height, but it isn't the radius, it's the diameter. So there's where the trick is. We're told that the diameter is 0.50, I think, millimeters. And then we know for a formula we need a radius. So that means we have to divide that in 2. So the radius is the diameter divided by 2, which is all well and good, but now we have millimeters for our radius, and our height is given in centimeters. We have to make a choice. Do we want to make them both millimeters or make them both centimeters? And the answer is, because densities are typically grams per cubic centimeter, even if they're grams per milliliter, that's the same as a cubic centimeter. Centimeters are the direction we want to head. So I need to remember that there's 10 millimeters in every centimeter. And so I have my radius now. So when I write wrong answers for a multiple choice test, So when I write wrong answers for a multiple choice test, one is I don't divide by 2, and the other is I don't change to centimeters. Okay, but now we can plug some things in.
Now I'm thinking about problem 132. Oh my gosh, stop. I was done with it.
Just be done. It's fine. And I'm going to continue on. I don't want to do this in 2 parts. So I'm starting with the volume, but now I'm going to use the density. And in my heart, I know this is a cubic centimeter. No problem. It'll cancel. Because here I have centimeters cubed, and here I have centimeters. So I can see the units cancel. Watching the units cancel is super important. My husband, who is a good man, a great man, and an excellent teacher, amazing teacher, was the best student 30 years ago, 35 years ago. And he passed an engineering class just because he could watch units cancel. He was so good at dimensional analysis that, and he knew equations like volume, that he could solve the problem. So watching the units cancel will save you a lot of grief. It's really important to always write the units in every step. Of course, I say that, and you will or you won't. But those of you that have conformed, that you've crossed over, you've been redeemed, you can probably appreciate units really can guide you. Okay, 14, we're going from miles to minutes, so we must need a rate. The rate is limited to sig figs. In this case, both the starting amount and the rate have 2 sig figs. We're going from miles to minutes. Our rate is given in minutes per second. No, meters per second. So I'll put meters on the length side and seconds on the time side. I can't go straight from miles to minutes, so maybe I'm going to need to go through kilometers. Two sig figs for 2 reasons. The initial distance, 2.5 miles, and then the rate, 4.4 meters per second. Okay, so now we're going from a volume to a time, which also requires a rate to cross over. And our volume is given in cubic feet. The time we're asked for is in hours. And the rate we're given is in gallons per minute. So I put gallons on the volume side and minutes on the hour side. And that's where the rate is going to cross us over between dimensions. So feet cubed, I'm going to go to inches cubed, centimeters cubed. Oh, it's a long path. Let me get some more space. Liters, quarts, gallons. It's a long path.
I'm gonna have to turn the paper sideways for this train track.
Yeah, it's who wrote this problem? It's terrible. Just terrible. Oh, would never do that on a test. Cruel and unusual.
Be because of the rate, it has 2 sig figs. Shouldn't it be 23?
Oh, you're totally right. Holy moly. I think I got that one wrong on the test. I mean, on the Kahoot.
Okay, cool.
Is that the one you missed?
Yeah, that one and number 13.
Okay, so you're 14 out of 15, but you still were number 1. So, okay, questions. I appreciate you pointing that out because I need to go fix that Kahoot in case I want to use it next semester.
Yeah, well, that one, it was just like so long. I was like trying to figure out kind of what happened, but we got it all figured out.